Hi all. Today we're going to move on to another piece of geometry and it's known as congruent triangles. You may or may not have heard of that term before. So a shape is congruent to another shape if it's identical in size and shape. So when we're talking about congruent triangles, we say that triangles which are identical in size and shape are called congruent triangles. So that's our new term, congruent. And we have a new symbol to go with it as well. So for instance, if I wanted to say that the triangle ABC was congruent to the triangle DEF, we have this symbol that's like an equal sign with an extra line. So it's like three horizontal lines instead of two. So triangle ABC is horizontal to triangle DEF. So I have two identical triangles here. They're congruent, but they're only congruent if we can show that they have the same length sides and the same size angles. Okay, then they're definitely congruent. So for instance, and this might be introducing some new symbols to you as well, or you may have seen this before. If the length of this side is the same length as this side, the way we show that in a drawing is that we give it a little tick like this to show that these two sides are the same length. And then if we want to show that AC is the same length as DF, well, we can't just give it a tick like this again, because then we're saying that this is the same size as this, and it's the same size as this, and it's the same size as that. And that's definitely not true, because this is a longer line than this. So when we want to do it for two other sides, we give it two ticks then, to show that this is the same length as this side and this is the same length as this side. And then if we wanted to show that BC was the same length as EF, well, three ticks and so on. So 1, 2, 3, 1, 2, 3, and this means that the length of the line segment BC is equal to the length of the line segment EF. So that's how we show that the sides are equal in length. And then if we want to show that the angles are equal in measure, as we say, well, if we wanted to show that the angle here, the angle BAC, is equal to the angle EDF, we sometimes use these little dots, and we can do the same thing again. We can put two dots here and three dots here. 3 dots here, 2 dots here, to show that all three are the same. Or some books use this symbol. They might go like this and this to show that they're equal, and maybe like two of these if they need to show more. So you can use the dots or those kind of curves. So what we've got here is this angle is equal in size to this angle is equal in size to the one with the two curves here, this angle is equal in size to this angle. So if all of the sides are equal in length and all of the angles are equal in measure, then definitely this triangle ABC is congruent to this triangle DEF. Okay? Now, the next thing we want to be able to do is we want to be able to show that triangles are congruent. And if we can show that all three sides and all three angles are equal in both triangles, then we have proven that the triangles are congruent. But sometimes we don't need to go that far, or at least we can show it in a slightly different way. So for example, let me just take another example here. For instance, if I wanted to show that this triangle was a right-angled triangle, all I would have to do was show that this was a 90-degree angle here. Okay? But that's not the only way of showing that that's a right-angled triangle. I could also show that that's a right-angled triangle by proving that the length of this side squared plus the length of this side squared is equal to the length of this side squared. And then even if I didn't know that was 90 degrees, I would know this was a right-angled triangle. Also, another way of showing that that's a right-angled triangle, if I knew that, for instance, this was a 30-degree angle and this was a 60-degree angle, well then, if the other two angles in a triangle add up to 90, 30 and 60 is 90, then it must be a right-angled triangle as well, mustn't it? Because altogether the three angles in a triangle have to add up to 180. So that's another way I could prove that a triangle was right-angled, if it had two other angles that added up to, or when you added them together, it came to 90 degrees, because 30 and 60 is 90 and 90 is 180. So for instance, this triangle here, Again, I wouldn't have to find out that this was 90 degrees because that's 45 and that's 45. I can say this is definitely a right angle triangle. So there are a number of ways that we can prove that something is a congruent triangle without having to show that every single one of these angles is the same as every single one of these angles, and every single one of these sides is equal in measure to every single one of these sides. Now I'm going to just follow this up in the next video.